What's going on, everybody? In this video, I'm going to share you the process on how we would find what is called the rate of change, the average rate of change of a function f of x. So it is going to be similar to the idea of the slope that we had for linear functions, which gives the rate of change for the linear function, but it's easy because it's just the slope of a line. The average rate of change, we translate this idea and apply it to functions that are not linear functions. So things like quadratics and cubics, anything that's a function, we can use the same idea as the slope, connecting 2 points on the function and creating a secant line between the 2 points, and then the slope of that secant line is what we call the average rate of change. So for just a linear function, the slope is equal to for just a linear function, the slope is equal to y2 minus y1 for x2 minus x1. But the more general sense, average rate of change, it's the same kind of idea, but instead of y2, y1, we're going to do f of x2 minus f of x1 over x2 minus x1, which is almost the exact same thing. So let's say that I had the function f of x is equal to negative x squared plus 8x minus 4, and the two x values in which I want to take the average rate of change across is 0 and 4. So if I want to find the average rate of change between these two x values, I first need to find what the function is equal at these two x values. So I want to find f of x1. What I would do is I plug in 0 in for x, because 0 is x1. So when I do that, I get negative 0 squared plus 8 times 0 minus 4. These two terms are going to cancel, and I'm just left with negative 4. And for f of x2, it's the same idea, but since x2 is equal to 4, I'm doing f of 4, so I plug in 4 for the x value. I'll have negative 4 squared plus 8 times 4 minus 4. This is going to give me minus 16 plus 32 minus 4, which just gives me a 12. So I've got all of the values that I need to apply to the average rate of change formula. So average rate of change is equal to f of x2 minus f of x1 divided by x2 minus x1. When I plug in my values, I have f of x2 is equal to 12, and f of x1 is equal to negative 4. x2 is 4, and x1 is 0. So this is going to give me 16 over 4, which is just equal to 4. So this is not to be confused with the instantaneous rate of change, but this is just the average rate of change across the two x values applied to this different function, applied to this particular function. The instantaneous rate of change is something that is touched upon extensively in a calculus course. Okay, for this example, I've got f of x is equal to 2 minus the square root of x plus 1. And the two values which I want to take the average rate of change across are x is equal to 3 and x is equal to 7. So again, what I'm going to do is I'm going to take my x1 value and plug it into the function. F of x1 is going to be equal to f of 3, which is going to be 2 minus the square root of 3 plus 1, which is 2 minus the square root of 4, which is just 2 minus 2, which gives me a 0. So it just so happens that 3 is a 0 of this function also. And I got to find my f of x2 value. So x2 in this case is 7, so I'll do f of 7. And this is going to be equal to 2 minus the square root of 7 plus 1, which is just equal to 2 minus square root of 8. And if I want to simplify that square root of 8, I've got 2 minus 2 times the square root of 2. And you can always factor that out. Factor out a 2 there and get 1 minus square root of 2. Same kind of deal. So if I want to find the average rate of change across these two x values, I've got the formula here. Average rate of change is equal to f of x2 minus f of x1 divided by x2 minus x1. Very similar to the slope formula. F of x2 is going to be 2 minus 2 times the square root of 2, or you can factor it out. I'm going to leave it factored. 2 times 1 minus root 2 minus f of x1, which is just 0, over x2, which is 7, minus x1, which is 3. And when I crunch the numbers here, I get 2 times 1 minus root 2 divided by 4, which just gives me 1 minus root 2 over 2 for my average rate of change. So hope this video was helpful about learning the process and how to find the average rate of change of a function in between 2 points. This is something that's going to be pretty important whenever calculus rolls around, because the idea of a derivative is finding the instantaneous rate of change of the function, but we'll cross that bridge when we get there. So I hope you guys liked the video. Stay tuned for the next one. Take care, everybody.